Welcome to the deep dive. So much of our digital world, the websites, the apps, the cloud services, it all runs on this kind of invisible infrastructure. And well, behind the scenes, there are system administrators using some really powerful tools to keep everything running smoothly, securely, performing well. Today, we're going to take a bit of a shortcut into their world, this deep dive. It's all about the essential Linux commands they actually use, like every single day out there in production. We're drawing heavily from a great article, 20 daily Linux commands system administrators use in production. It really cuts through the thousands of commands to find the absolute must-haves. So our mission for you listening in is to get a really quick, solid grasp of these key commands, not just what they do, but why they're so critical. Think of it as learning the basic language of server management. Doesn't matter if you're new to this or just want to brush up. We're pulling back the curtain a bit. Okay, let's unpack this. First up, commands for monitoring system health. Keeping an eye on the server's pulse, basically. Let's start with htop. You might have heard of top.
Well, htop is like its modern, much friendlier cousin. Supercharged, really. It gives you this interactive real-time view, CPU, memory, swap usage, plus a nice process tree showing what's running. And the best part is how easy it is. Arrow keys to scroll, F6 to sort things differently, F9 to kill a process if it's gone rogue. Way easier than finding PIDs manually.
That's right. htop is definitely the go-to for many admins now.
Mm-hmm.
But, and this is important, the old top command, it's everywhere. It often comes pre-installed, especially on really minimal server setups. So if you land on a system and htop isn't there,
knowing top is your fallback.
right, exactly. You can always get that quick system overview. So knowing both, it gives you real flexibility in the field.
Flexibility is definitely key. Okay, and speaking of quick checks, memory usage is vital, isn't it? That's where free comes in. Super simple command. Just shows you your RAM total used, available, and also your swap space. That's the disk space used, like extra RAM when you run low. Quick tip here, use free H. The H means human readable. Turns bytes into MB or GB. So much easier on the eyes.
Makes a huge difference.
And it's the same idea for disk space with DF. That stands for disk file system. It shows how much space is used and free on all your mounted file systems, all your drives and partitions, essentially. And again, DFH. Use the H for human readable output in GB or TB. Really important for just, keeping tabs on things.
Absolutely. And the critical thing about free and DF, I think, is that they're your early warning system. You see memory usage creeping up or disk space running low.
Oh.
You can spot those problems before they actually crash an application or halt the system.
Ah, yeah. Proactive is better than reactive.
Definitely. Spotting those growing log files or a memory leak early saves a lot of headaches. These commands let you do that.
Makes sense. And if DF shows a partition is getting full, but you need to know what inside it is taking up space.
That's disk usage.
Right. So say your var directory is huge. You could run douche var.
Exactly. Disk for summary, DH for human readable. It'll show you the size of each thing directly inside var, helping you pinpoint the culprit, like weighing your folders.
Nice analogy. Okay, last one for this monitoring section.
Okay.
Uptime. Simple command, but tells you quite a bit. How long the system's been running without a reboot, how many users are logged in, and crucially, the load averages over the last 1, 5, and 15 minutes.
And that load average is key. It's a measure of system busyness, essentially.
Yeah, how many processes are actively running or waiting for the CPU? Like, a load of 1 on a single-core CPU means it's perfectly busy. A load of 2 means things are queuing up.
So high numbers mean you might have a bottleneck, a potentially overloaded system. Uptime gives you that quick glance.
Oh, wait, so we got monitoring covered.
Yep.
Now let's shift gears a bit. What about when things go wrong? Debugging.
Right, this is where things get really interesting. These next commands are like your diagnostic tools, your magnifying glass for figuring out system behavior. When something isn't working right, these are often the first commands you'll reach for, understanding what processes are actually doing.
Let's kick off with less off. List open files. Sounds simple, but it's incredibly powerful, isn't it?
Oh, yeah. It tells you which process is using a specific file or a directory or even, crucially, a network port.
Like the classic example, your web server fails to start. Says port 80 is already in use.
Happens all the time.
So you run lsaf i.80, and bam, it tells you exactly which process ID, which user, which command is blocking that port. It's like X-ray vision for process interactions.
It really is. And for modern systems, another indispensable tool is journalctl. This is how you access the system logs on distros using systemd. And, well, systemd is pretty much the standard now for managing services in boot up.
So journalctl brings all the logs together.
Pretty much, yeah, it consolidates things. So journalctl E is super common. Shows recent logs, delects, adds helpful explanations. E jumps you to the end. Great for spotting errors quickly.
And if you need logs just for one specific service, like, say, Nginx.
Easy. Journalctl unjink
Yeah.
for unit, which is what system calls a service. Filters right down.
Okay, and if journalctl shows an issue with the service, the command to actually manage that service is systemctl, right?
Exactly. Since system manages the services, systemctl is your control panel.
So you can start, stop, restart services, check their status.
Yep. Systemctl status Apache 2 to see if Apache is running. Systemctl restart stanj to restart the SSH service. Systemctls enable Nginx to make Nginx start automatically when the system boots.
Got it. Fundamental stuff for service management.
Absolutely. Then there's PS.
Ah, the process snapshot.
Right. It gives you a complete list of every single process running at that moment.
Yeah.
Shows the user, PID, CPU usage, memory usage, the command itself, everything.
And you can combine it with grep, can't you? Like PO's grep Apache to just see the Apache processes.
Or, a really useful trick, PO sort %mem in head. That sorts all processes by memory usage, highest first, and shows you the top few. Instantly spots memory hogs.
Nice. Okay, one more for logs, tailmemf, the live log watcher.
A lifesaver for real-time debugging. The of means follow. It just keeps printing new lines to the screen as they get written to the log file.
So you can watch things happen as they happen.
Precisely. You could tailmef varlog messages for general system stuff, or combine it like tailbiff or slug grep such to watch only SSH activity live. Great for troubleshooting connections.
Okay, so we can monitor, we can debug processes and logs. What about the network? A server needs to talk to the world, right?
Absolutely. If you connect this to the bigger picture, communication is everything. So these next commands are your essential toolkit for network health and diagnostics.
Let's start with checking connections. Used to be netstat, but now it's mostly SS, isn't it?
Yeah, socket statistics is the modern replacement. It's faster, better maintained.
And a common usage is stun. What's that doing?
Okay, ST is for TCP connections, T for your UDP. SL shows listening socket services waiting for connections. And SAN shows numeric addresses instead of trying to resolve host names. Speeds it up.
So it gives you a quick list of all the ports your server is listening on and any active connections.
Exactly. Quick network overview.
And for managing the network interfaces themselves, IP addresses, routing.
That's the IP command now. It replaces the older ifconfig and rogue commands. If you learn those, it's time to switch to IP. It's standard everywhere now.
Okay, so what are the key IP commands?
Two main ones you'll use constantly. IPA, that's short for IP address show, shows all your network interfaces and their IP addresses. And IPR, short for IP route show. That displays the system's routing table. Tells you how your server sends traffic to different networks. Fundamental stuff.
Got it. IPA for addresses, IPR for routes. Simple enough. Now, the absolute classic network test, ping.
Can't be ping for a basic connectivity check, can you? Sends a little echo request using ICMP and waits for a reply.
Just ping google.com tells you if you can reach the internet.
Right. And maybe add -C4, like ping-c4 google.com, to send just 4 packets instead of letting it run forever. Good practice.
Yeah.
First thing you try if something seems offline.
But what if ping works, or maybe it doesn't work, and you need to know where the problem is along the path?
Then you need traceroute. Or sometimes tracepath does a similar job.
So this shows the whole journey.
Yeah, it lists every hop, every router your packets go through to reach the destination. So if traceroute google.com suddenly stops or shows high latency at a certain point,
You know where the bottleneck or the break is, even if it's outside your own network.
exactly. Crucial for diagnosing those trickier connection problems.
Okay, one more network tool.nc-netcat, the Swiss Army knife.
Yeah, it does a lot. But for sysadmins, a really common use is just testing if a port is open on a remote server.
So not just checking your own listening ports with SS, but seeing if you can actually reach a service on another machine.
Right. Is the firewall blocking it? Is the service even running over there?
Yeah.
NC-NEV IP address port is great for this.
Let's say NCD-ZV 192.168.1.1022, checking SSH port 22 on that IP.
Yep. SDO just scans, doesn't send data. -EV gives you verbose output. It'll tell you quickly if the connection succeeded or failed. Super handy for verifying firewall rules or service status remotely.
Okay, this is great. We've covered monitoring, debugging, networking. So what does this all mean for just like the daily grind? Managing files, automating things?
Yeah, this next batch is all about control and efficiency. File management, automation structuring your work, and streamlining operations.
Let's start with the basics of security. File permissions. Chan and chown.
Absolutely fundamental. John change mode sets permissions. Who can read, who can write, who can execute a file or access a directory.
Like chmod 755 script.ha to make a script executable.
Right. And chown change owner sets who owns the file and which group it belongs to. Chown user.userfile.txt.
Getting these right isn't just about access, it's critical for security, right? Preventing unauthorized changes or access.
Definitely. Misconfigured permissions are a common way systems get compromised. Mastering chon and chown is step one in hardening a system.
Okay, how about finding files, especially on a big system?
That's where find comes in. It's incredibly powerful. You can search for files based on name, size, type, modification time, ownership, almost anything.
So finding all .log files in varlog would be?
Find varlog-name.log. Simple enough, but where it gets really powerful is combining it with actions.
Like automated cleanup.
Exactly. Find keep apties fftzio plus 7 delete. Find regular files per TBP modified more than 7 days ago, 15 plus 7, and delete them. Automates keeping directories clean.
Very useful. Now, moving files around, especially between servers. Backups.
Esync is the king for that. It's designed for synchronizing files and directories, even over the network, using SSH.
How's it different from just copying, like with CEP?
Greasing is smarter. It only transfers the differences between the source and destination. If a file is only changed slightly, it just sends the changed bits.
Ah, so much faster and uses less bandwidth, especially for large files or repeat backups.
Massively so. A typical backup command might look like suresync evis data user at remote.backup. dfa for archive mode, reserves permissions, ownership, etc. doofy for verbose, sneezy for compression, efficient and reliable.
Okay, last one, and it's a big one for efficiency.
Yeah.
Automation with cron tab.
Yeah, cron is the built-in Linux task scheduler. Cron tab is the command you use to edit your personal schedule, your cron table.
So this lets you run commands or scripts automatically at set times.
Precisely. Daily backups, weekly log rotation, running checks every hour, anything repetitive.
How does the scheduling work?
It uses a 5-field format. Minute 059, hour 023, day of month 131, month 112, and day of week 07, Sunday 07. Then the command.
So it's 02 usobin-backup.esh means?
Run a serabandbackup.esh at minute 0 of hour 2.
Yeah.
Every day, every month, every day of the week. So 2.0 a.m. daily.
Wow. Mastering that could save huge amounts of time, couldn't it? Taking care of all those routine tasks automatically.
Absolutely. And that raises a bigger point, doesn't it? How much time can mastering automation tools like cron save you, really, in any field, just by eliminating repetitive work? It's huge.
That's a great point. Okay, so that wraps up our tour of these 20 essential Linux commands. We've seen how they cover monitoring, digging into issues, handling network tasks, managing files, and automating jobs. As the source article stressed, getting good at these really boosts your efficiency. They're the core toolkit.
The daily drivers for most sysadmins.
And even if you're not managing servers full-time, just understanding these gives you such a better insight into how these systems work, how robust Linux is. It really empowers you to navigate and control these digital environments much more effectively. It's valuable knowledge for almost anyone interacting with tech today.
Definitely. It demystifies a lot of what goes on under the hood.
So here's a final thought to leave you with. Think about your own daily work, digital or maybe even analog. What are your essential tools, your top 20 commands or actions?
And how could really mastering those, doing a deep dive into your own core tools, unlock new levels of efficiency and understanding in whatever it is you do? Something to think about.